Question 1 asks us to find and draw the cumulative probability and probability distribution of y in terms of cumulative probability and distribution of x. And we're given the relationship of y and x. And what we can see here, there's only one interval in which y and x are related, and that is when x is between 1 and 2. And in this interval, y is minus x plus 1, and in all other intervals, y is just some constant number. So y and x are not related in these other intervals. And also we're given the probability distribution of x, which is, you can say it's a normal distribution. Yeah, and then let's just try to find the cumulative probability and density. So we can just do it the old-fashioned way. So the cumulative probability y is when the variable y is less than small y. And that y, when that y is correlated with is related to x, we can substitute y with minus x plus 1, and then therefore we can know that is the probability when x is larger than 1 minus y, which is the complementary part of probability when x is less than 1 minus y, and that is the cumulative probability value. So that is the probability of x happening before or on the left of 1 minus 1, right? So we have 1 minus cumulative x 1 minus y here. So we have already found out the relationship of cumulative probability y and x in this interval, which is 1 to 2, right? So when x is between 1 and 2, we can find out that y in correspondence is between minus 1 and 0. Right, so when y is between minus 1 and 0, we can just have this curve pretty much we're getting 1 minus fx 1 minus y here. Yep, so pretty much we're flipping the okay, so we're intersecting the interval when x is between 1 and 2, and then we're kind of like, we're just flipping that. Yeah, to when y is between minus 1 and 0. And there are some other values we can find out. That is when y is equal to 2 and 0. So when y is 2, that only that's only when y is negative. So we have the value cumulative probability at 0. And also probability when x is between 0 and 1 is probability when x is less than 1 minus the probability when x is less than 0. So here we have cumulative x1 and minus cumulative 0. And so on and so forth. We can have a graph like this one. This would be the distribution function, distribution of y. Yeah, so we have three different impulses and one curve that is just a little fraction of this big fx. Sorry, this distribution function of x. And with that in mind, it's really easy for us to find out the cumulative probability of y, right? So pretty much every impulse function kind of reflects a step, kind of. So we would just go straight up. So when y is -1, we go straight up and we reach the value of 1 minus cumulative x 2. And here we have this curve, and then at y equals 0, we also have an impulse. We jump to 1 minus cumulative x 0, and then also a little step here when y equals 2.